Good morning, guys. Welcome to the second video lecture of ME263 Machine Elements. So in this video, I will be discussing to you the degree of freedom. So the degree of freedom, also known as the degree of mobility, it is used to define the number of parameters or variables to describe the overall movement of all links in the mechanism. So, in other words, if you have a degree of freedom, so kapag meron kang input motion, ang hinahanap natin, ilang output motion ba yung mabubuo natin. So, kung ilang output motion yung mabubuo, that will become the number of degrees or the degree of freedom ng mechanism natin or the degree of mobility. So, let's talk about translational movement. So, we have three translational movement. First is the surge, or the moving of forward and backward of an object. Next, we have an heave. The heave is the moving of up and down motions. Next, we have sway, or the moving of an object from left to right. So, in other term or other terminology, we can say that an object can move in X, Y, and Z axis. Next, let's talk about rotational movement. So we have roll, pitch, and yaw. The roll is the tilting or the rotation by side to side. Next, the pitch is the tilting forward and backward. Next, the yaw is the turning left and right. So as you can see, the roll is the rotation on the y-axis. Pitch is the rotation on the x-axis. And the yaw is the rotation on the z-axis. So therefore, an object can move into 6 degrees of freedom. So meron tayong 6 degrees of freedom ng isang object o kaya sa pinag-uusapan natin in mechanism. So meron tayong 6 degrees of freedom in a mechanism. So let's talk about Grueber's equation. Grueber's equation, it is used to estimate the degree of freedom of mechanism and written as DOF is equals to 3 quantity n minus 1 minus 2j minus h. So the n is the number of links in the mechanism in which one is fixed. Lagi yan. If you are given a mechanism, the one link is always the fixed link. Next, we have the j. J is the number of lower pairs. H is the number of higher pairs. So in order for us to understand the formula or the Grueber's equation, let's try it on an example. So we have here a parallel mechanism. So kaya siya tinawag na parallel mechanism because the linkages are parallels. So let's try to solve this problem. So our formula is DOF is equals to 3 quantity n minus 1 minus 2j minus h. So first, let's try to count how many number of links are there in this mechanism. So first, we have L1. We have L1. The L1 is the frame of the mechanism. L2, the crank or the one that rotates the mechanism. We have the floating link, L3, and another link, L4. So if we count it, we have 4 number of links in this mechanism. Next, we will count the number of lower pairs in the mechanism. First, we have a revolute pair here, another revolute pair, another revolute, and lastly another revolute. So there are 4 revolute pairs in the mechanism. A revolute pair is an example of a lower pair. So yun lang. Next, The number of higher pair in this mechanism is 0. Wala tayong meshing of gear teeth o kaya common follower dito. So our higher order pair is 0. Solving for the degrees of freedom, our DOF will be equal to 1. Meaning, our mechanism can move at one motion. So, ibig sabihin, pag gumalaw tong crank na to at counterclockwise, gagalaw din or susunod din yung other mechanism or other linkages sa kanya ng isang beses lang. Next example, mating of two SPUR gears. So, imagine we have two SPUR gears here. This one will be the driven gear and the smaller one will be the driving gear. So, yung driving gear natin is rotating at counterclockwise. Siyempre, kapag gumalaw na yun ng counterclockwise, the opposing gear will move at clockwise direction. So, let's solve for the degrees of freedom of this mechanism. So, let's count the number of linkages in this mechanism. So, first, we have the frame, L1. We have L2, this driven gear, and L3, the driving gear. So our number of linkages in this mechanism is 3. Next, let's count the number of lower pairs in the mechanism. First, we have a revolute here, wherein the gear is rotating, and another revolute here, wherein the driving gear is rotating. So we have two number of lower pairs in the mechanism. Next, let's count the number of higher order pair. Our higher order pair will be equal to 1 because we have two mating gears here. So meron tayo one higher order pair. So solving for the degrees of freedom of this mechanism, 3 quantity 3 minus 1 minus 2 times 2 minus 1, our degree of freedom is 1. Meaning, kapag gumalaw tong driving natin, one direction lang din ay gagalaw ng another link natin. So gumagalaw lang tayo ng rotational, hindi tayo nagta-translational, hindi rin tayo nagbabago ng ibang axis. Next example is a slider and crank mechanism. So in a slider and crank mechanism, this link is considered as the crank, which rotates 360 degrees. So when this link rotates, this slider will follow. So let's compute the degrees of freedom of this mechanism. So let's count the number of links in the mechanism. So we have 4 number of linkages in the mechanism. The first link will be the frame. The second link will be the crank. L3 will be the floating link or the connecting link. And L4 will be the sliding link or our slider. Next, let's count the number of lower pair in the mechanism. First, we have a revolute here, another revolute here, another revolute, and then a sliding or a prismatic pair here. So we have 4 lower pair, 3 revolutes, and 1 prismatic pair. Next, the number of higher order pair in the mechanism will be equal to 0. Solving for the DOF or the degree of freedom, 3 multiplied by 4 minus 1 minus 2 times 4 minus 0, the degree of freedom will be equal to 1. Which is correct. By observing the mechanism, kahit hindi ko gamitan yan ng DOF, malalaman ko kagad yan ng degree of freedom is 1. Because kapag umikot to at a certain axis, ang motion din ng other link is at the same axis. Hindi na sila gagalaw ng other motion. Next example, example number 4 is the knife type come and follower. So as you know, the come and follower is a higher order pair. So this gray part or dark gray part will be the come, and this light gray part will be the follower. So this come rotates and this follower slides across this frame. So sliding siya, ito rotational. So let's try to solve the degree of freedom of this mechanism. Ilang bang motion yung nabubuo ng mechanism natin? Okay? First, let's count the number of linkages included in the mechanism. So we have L1. L1 is the frame wherein the cam is connected. L2 is the cam itself. L3 is the follower sliding to the frame. So the number of links included in this mechanism is 3. Next, let's count the number of lower pair in the mechanism. So 1, we have revolute wherein the cam is rotating. And 2, we have this slider here in which the follower sliding. So we have 2 lower pair, 1 revolute, and 1 prismatic. Our higher order pair count will be equal to 1 because this is a cam and follower mechanism. Isang cam and follower lang, kaya isa lang yan. So solving for the degree of freedom, DOF is equals to 3 multiplied by 3 minus 1 minus 2 times 2 minus 1 will be equal to 1. So ibig sabihin, one given motion, kapag umikot to, one equivalent motion din yung mabubuo natin. Okay? Next. Example number 5 will be the roller type come and follower. Almost the same as kanina. The difference lang between these two is the geometry of the follower natin. Sa follower kanina, that is a knife type. Pag sinabing knife type, pointed yung follower natin. In this come and follower type, our follower has a rollering hit. So, ibig sabihin, itong cam gumugulong dun sa follower natin. Or sumusunod yung follower natin, yung gulong ng roller natin dun sa ikot ng cam natin. Let's try to solve our DOF. So, let's try to count how many links are there. So, we have L1, the fixed link. L2, the link or the cam. L3, which will be the roller natin. L4, that will be the follower itself. So the number of linkages in this mechanism is 4. Now, let's count the number of lower order pair. For the lower order pair, we have 1, which is the revolute here, in which the cam is rotating. Another one will be the revolute here, in which the roller is rotating. And lastly, we have a slider here, or prismatic pair. So we have 2 revolute and 1 prismatic, equal of 3 lower order pair. Next, we have 1 higher order pair because this is a 1 cam and follower. So solving for degree of freedom, we have 3 multiplied by 4 minus 1 minus 2 times 3 minus 1. The answer of our degree of freedom will be 2, which is correct naman because we have the motion of the follower here, which is linear, and we have the motion of our roller here, which is rotational. So kapag umikot yung cam natin, dalawang motion yung mabubuo natin. Isang translational for the follower and 1 rotating for the roller natin. Next example is a crank and slotted lever mechanism. So a crank and slotted lever mechanism is an example of quick return mechanism. So, i-discuss natin yan sa mga future videos natin, kung ano ba meaning nila. So, in this mechanism, this BC is our crank, in which it rotates in full rotation, 360 degrees. Okay? And link AD is oscillating. Kapag umikot tong crank BC natin, mag-o-oscillate tong AD. Kapag nag-oscillate tong AD, may connected kasi sa kanya ng ED. So, susunod si ED. So, yung ED, yun yung humihila sa slider E natin. So, that is the crank and slotted lever mechanism. So, let's solve for the degrees of freedom of this machine or mechanism. So, first, we have links AB. So, isa na yan. Yung link AB natin, that will be the frame. BC, the crank. AD, the rocker or the lever natin. DE, the floating or the connecting link. And slider C. This slider C moves or slides in AD. And another slider which is slider E. Yung nag-i-slide dito sa imaginary line na to. So total of 1, 2, 3, 4, 5, 6. We have 6 links all in all in this mechanism. Okay? Next, the number of lower order pair will be equal to 7. So bilangin natin ba't naging 7 yan. So una, we have revolute here. Another revolute at this slider. Revolute ulit dito sa point A. Revolute at point B. And revolute at point E. So total of 5 revolutes. Okay? So another pair na makikita natin dito sa mechanism na to is slider. So si slider C and slider E. So yung slider na yan, that is a prismatic pair. So we have 2 prismatic pair. A total of 7 lower order pair. So for the higher order pair naman, 0 yan. Kasi wala naman tayong gear o kaya wala rin naman tayong common follower dito. All linkages natin is connected by joints. Puro linkages ang gamit natin. So solving for the degree of freedom, 3 will be equal to 3 multiplied by 6 minus 1 minus 2 times 7 minus 0, our DOF will be equal to 1. So 1 input motion will be equal to 1 output motion. Isang output motion lang mabubuo natin, which is translational dito. Okay? Next, we have example number 7. As you can see in this example, this is almost similar dun sa example number 1 natin. But the difference is we have an additional link here in between. So let's try to solve using the GRUEBLER'S equation. So let's count how many links are there. So we have L1 will be the frame, L2 the rotating link, L3 isang buo na yan, that is the connecting links, L4 yung intermediate link dito, and L5 yun yung follower link natin. Okay? So the total number of links in this mechanism is 5. Next, counting for the number of lower order pair, we have 1 here for the revolute, another one here, another one revolute here, another revolute, revolute, and revolute. So a total of 6 revolute pairs or 6 lower order pair in the mechanism. For higher order pair, it will be equal to 0. So solving for the degree of freedom of this mechanism, so DOF will be equal to 3 times 5 minus 1 minus 2 times 6 minus 0. That will be equal to 0. Kapag 0 yung DOF natin, meaning structure to. Kasi kapag nag-input ako ng motion dyan, 0 yung output motion mo. So walang galawan linkages mo. That is considered the structure. Kaso pag inobserve ko tong mechanism ko, parang may mali. Bakit parang may mali? Kasi alam ko kapag minove ko yan, susunod tong other links na to, yung L4, L5, and L3. Susunod yan. Kasi revolute pair naman yan eh. So parang hindi na satisfy ng Grubler's equation yung degree of freedom na dapat lalabas. So by looking in the mechanism, it should have 1 degree of freedom. Kasi dapat kapag umikot to, or kapag meron tayong isang input motion, dapat may isa ding output motion. Pero by this, 0 ang lumabas. May mali. Hindi gumana yung Grubler's equation natin. Ang tawag natin dito sa mga gantong mechanism is Grubler's equation paradox. Grubler's equation paradox. So ang tawag natin sa mechanism natin na ito is Grubler's equation paradox. So to satisfy or to correct that problem, we have a tip here. So before solving the DOF of a mechanism, check if it has a redundant link. Ano ba ibig sabihin ng redundant link? Redundant link doesn't contribute to the motion of the mechanism, such as intermediate link 4 natin. Kasi nabubuo naman yung mechanism natin kahit tanggalan mo ng link dyan. So either L2, L4, or L5, walang contribution yan basta tinanggal mo yung isa doon. Okay? Meaning, kapag tinanggal ko kunyari yung L2, mag-move pa rin naman to. Kunyari, ito yung naging crank natin. One input link natin, makakapag-produce tayo ng one output motion natin. Kapag tinanggal ko naman yung nasa gitna, which is L4, ito yung ginawa kong crank, one input motion natin will be equal dapat sa one output motion. And kapag tinanggal ko naman yung L5, ito tinira kong dalawa, L2 and L4, kapag ito yung minove ko, one output motion din yung mabubuo. So, ibig sabihin, in this mechanism, we have a redundant link. So, yung redundant link na yun, pwede natin tanggalin. So, kapag binilang ulit natin yan, mababawasan na ng isang link. So, we have L1 the frame, L2 here, L3, and L4. So, 4 lang yung number of links dapat natin. Lower order pair natin, 4 din kasi meron tayong 4 na natirang revolute pairs. For higher order pair, wala nang matitira kasi syempre hindi naman talaga siya higher order pair at the first place, no? Puro linkages kasi ang gamit natin. So, solving for the degree of freedom, ang lalabas na dyan is 1. So, this tip, or yung binanggit ko na tip kanina, yun yung dapat tinitingnan natin muna yung mechanism bago natin solve yung Grubler's equation. Kasi hindi na satisfy lagi ng Grubler's equation yung dapat number of links natin. Kasi minsan meron tayong tinatawag na redundant link or yung link na hindi nakakapag-contribute dun sa mechanism natin or sa motion ng mechanism natin. Okay? Ang tawag natin kapag ganun, may redundant link, that is Grubler's equation paradox. That will be the end of lecture. If you have any question, you can message me either on Messenger or on my email.